Good evening and welcome to those of you just tuning in. Breaking news, solving systems of equations by graphing was found dead in a ditch this morning. We're receiving word that the prime suspect is still on the loose and all the cool kids are doing it, a bold new method for solving systems called substitution. Hence the title of our lesson today, Class 3 of Unit 5, Solving Systems by Substitution, Part 1. Now, as we've said time and time again, we know that by solving something, our goal is to make it true. For systems, of course, making it true means something really specific. Remind me, what did we say last class about what it really means to solve a system of equations? Take 10 seconds, pause the video, go! Okay. To solve a system of equations, what we are really doing is looking for values of x and y that make both of our equations true, or values of any pair of variables, it doesn't really matter. We know that what we're really looking for is a point that's on both of our lines then, which means what we're actually identifying is the point where our lines intersect. One way that we can identify a solution to a system is by graphing. And graphing is great, but it can be kind of tedious. It takes a long time to graph. We have to hope that we find the point of intersection. We have to check our work, meaning as mathematicians, it is our legal sworn duty to ask, is there a more efficient way? So for example, take this guy, the first problem that we solved together last class. Y equals negative x plus 5 and y equals 2x minus 1. We saw by graphing that its solution was the ordered pair 2, 3. In other words, when x equals 2 and y equals 3, both of these equations are true. We want a way to find the solution algebraically without going through all the hassle of graphing. What do you think a possible strategy might be? And I'll give you a hint. It might be something to do with the title of the lesson. Take 30 seconds, take a risk, take a chance. Not necessarily expecting you to get all the way there, but what do you think we might be able to do to find the values of x and y that we're looking for? Go! Alrighty, stop going. So, hopefully, the fact that our title is substitution gives you a hint that something to do with substitution is probably going to get us to where we want to go. As a really quick aside, do you remember all the way back from Unit 0? We've done some of it in the process of checking our work, but do you remember how to evaluate an expression? So say 5n minus 8 is the expression I want to evaluate, and I want to evaluate it, do so when n equals negative 2. Take 10 seconds, pause the video. How would I evaluate this expression? Go. Alrighty, well what I'm saying here is that n is equal to negative 2 in this specific case. So in my expression, anytime that I see an n, I can use the property of substitution to replace n with the equivalent statement of negative 2. And then from there I could simplify. This would become negative 10 minus 8, which is equal to negative 18, yada, 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 whatever. Look at the problem up above. I'm saying that y is equal to negative x plus 5, y is equal to 2x minus 1. Both of these lines happen to be in slope-intercept form. That doesn't really matter. They can be in any form. But what's important about these is that both of them have a variable that's isolated. Here, I'm saying that y is equal to negative x plus 5, but it's also equal to 2x minus 1. By substitution, say for example, I just look at that first equation. If y is equal to negative x plus 5, that means y is interchangeable with negative x plus 5. So what's stopping me from replacing the value of y in the second equation with the value of y from the first equation? So doing some substitution, if y equals negative x plus 5, then that means that negative x plus 5 can take the slot of y in the second equation, and then that's equal to 2x minus 1. All I need to do now is find a value of x, and I know how to solve this equation for x. Let's do it together. I want to show that I get x equals 2. Well, let's start here by changing the fact that I have x's on both sides. Maybe I'll start by adding x to both sides. Lots of different choices I can make here. It doesn't really matter which one you do. So here, 5 is equal to 3x minus 1. Now I want to get x by itself, so I have a negative 1 on both sides, or on the right, I'll add 1 to both sides to get rid of it. 6 is equal to 3x. To get x by itself, let's divide both sides by 3. That tells me that 2 equals x. And would you look at that? There's that value of 2. that we wanted. So I've got the value of x. And now I'm done, right? Well, no, right? I still need y. So think strategically. I know now that the value of x that I want is 2. How could I use that value of x to find the value of y? Go ahead, take 30 seconds, pause the video. What do you think? Okie dokie, well, I know x equals 2. I still need to find my other variable. In order to do that, all I probably need to do, again, it's in the name, is substitute. So I know that I want x to be 2. Let's take one of my two equations above. Maybe I'll take the first one here. So I'm going to take that guy. Y is equal to negative x plus 5. But I've just found that x is equal to 2. So I'm going to take my value of x and replace it by substitution. So I'm going to say y is equal to negative 2 plus 5. Negative 2 plus 5, well, that is 3. And would you look at that? There's the value of 3 that I wanted. Congratulations! You now know how to solve a system of equations algebraically using this method that we're going to call substitution. So to solve a system algebraically, aside from the graphical method we learned last time, there are two main methods that mathematicians use, the first of which we have just discovered. It's called substitution. And the idea behind the way that it works, actually, you tell me. What do you think we need to do? There were two main steps that we needed to follow. What were they? 30 seconds, pause the video. What do we need to do to solve by substitution? Go ahead. Alrighty, well, if I want to solve a system by substitution, the first thing that we needed was something with a variable that was isolated. So I want to begin by isolating a variable term in one of our equations in our system. And once we've got a variable or a variable term isolated, from there all I need to do is substitute or plug it in into the other equation in our system. So same idea. Say that I've got this guy, p equals 2m plus 13, and p equals 3m plus 2. Notice in the first and the second equation, p is isolated. Substitute into the other equation and see if you can find a value of m. And then once you've got it, you need to use that value of m to find the value of p. Go ahead, take 2 minutes, pause the video. Take a risk, take a chance, who cares? See if you get it. Go! Okay, so here, let's switch it up. Maybe I want to plug the first equation, or the second equation into the first equation. So here, I know that p is equal to 3m plus 2. I'm going to take that 3m plus 2 and replace the p in the first equation with that expression. So from here, I know that p, which is equal to 3m plus 2, is going to be equal to 2m plus 13 using substitution. So all I need to do is solve for m. To do that, maybe I'll start by subtracting 2m from both sides. I could have subtracted 2, I could have subtracted 13, could have subtracted 3m, doesn't really matter. From here, I get m plus 2 is equal to 13. All I need to do to get m by itself is subtract 2 from both sides. That tells me that m is equal to 11. So now I've got a value of m. I still need a value of p. Well, in order to do that, let's substitute. Doesn't matter which equation, maybe I'll substitute into the bottom equation. So I know that p is equal to 3m plus 2. So if I take the value of m and replace it with the 11 that I just found, that should be able to help me find the value of p. So from here, I get p is equal to 33 plus 2. 33 plus 2 is equal to 35. And if you happen to go back to that first word problem that we solved, you'll notice this is the same system of equations from that word problem. This is the solution that I presented you with. Feel free to check if you don't believe me. Cool. Now, This is a totally acceptable way to leave your answer. All we need is a value of m and a value of p. But remember, what we're really doing is finding a point of intersection. So if you're interested, optionally, you can also write this as an ordered pair. What order do you think you would need to write these variables in order for this to be a valid ordered pair? 10 seconds, pause the video, go. 5, 4, 3, 2, 1, and stop. Well, an ordered pair is in alphabetical order. So I just need to ask myself, does M or P come first in the alphabet? Well, M comes before P in the alphabet, so the ordered pair corresponding to this solution would be 11 first, because M comes before P, followed by 35. Now, you do not need to write your answers as this. I personally like it because it reminds me that I am actually finding a point on both lines. But leaving it as just two values of a variable is also totally fine. Fantastic. Uno más. G equals 2h plus 5, 4g plus 3h equals 9. Notice in the first one you've got something by itself. Maybe you want to use that to your advantage. Let's solve this guy by substitution. Take 2 minutes, find the values of both variables, and if you want to, express it as an ordered pair. Go ahead. Okay, so in our first equation, g is by itself. That tells me anytime that I see a g in the second equation, I can replace it with 2h plus 5. So by substitution, that tells me that 4 times the value of g, which is equivalent to 2h plus 5 plus 3h is equal to 9. All I need to do now is solve for h. So I'm going to start by doing some substitution, some distributive property. 4 times 2h gives me 8h. 4 times 5 gives me 20 plus 3h equals 9. Next up, notice I've got some like terms on the left I can combine. So I'll say 11h plus 20 is equal to 9. Subtracting 20 from both sides to get h by itself, I get 11h is equal to negative 11. And finally, dividing both sides by 11, that tells me that h is equal to negative 1. Now that I have h by itself, I want to use it to find the value of g. Now pause for a second. Put your critical thinking caps on. Which of the two equations here would it strategically be wiser to substitute this value of h into? 10 seconds, pause the video. Which one is wiser and why do you think that is? Go. Alrighty. For me, if I'm thinking strategically, my goal is to find g. Notice that the top equation already has g by itself, which means that of the two equations, this is probably the easier equation for me to substitute this value of h back into. So by substitution, I'm going to take g equals 2h plus 5, and I'm going to replace that h with the value negative 1 that I just found below. You could, of course, use the other equation. It doesn't matter. This one is just a little bit more efficient. So from here, I get g is equal to 2 times negative 1, which is negative 2, plus 5. Negative 2 plus 5 is equal to 3. So g equals 3 and h equals negative 1 as an ordered pair. If you're interested, again, this is totally optional, but which one comes first in the alphabet? Well, g comes before h. So as an ordered pair, I would write this as the point 3, comma, negative 1. Either of these two forms, either just your two variables with isolated values, or your ordered pair notation is fantastic. Cool. So there's the idea behind substitution. Now we'll amp this up even more next time, but just a preview of what's to come. Sometimes the substitution that we need to do will not always be quite so obvious. We might need to do a little bit more work. So for example, one more for the road. Let's say I've got this guy, a plus b equals 7, 2a minus 3b equals negative 11. My goal is to plug one isolated variable into another equation. The problem here is that I don't have a variable that's isolated in either of my two equations. How do you think I might remedy that decision? Alrighty. Well, hopefully, if I take any one of my two equations, all I need to do is get one of my variables by itself. Let's say that I take this top equation here. A plus B equals 7. I need an isolated variable. Well, let's say that I want to pick A to get by itself. I could choose B to get by itself. It doesn't really matter. But I'm going to pick one of my two to isolate. Let's say I choose A. Subtracting B from both sides, that gives me A is equal to 7 minus B, or A is equal to negative B plus 7. It doesn't really matter. It's the commutative property. Now, I know that A is by itself, which means that anytime I see an A in the second equation, I can replace it with the now equivalent statement of 7 minus B. Would you look at that? We can do some substitution. Let's do it. So from here, that tells me in my second equation that 2 times the value of A that we found, 7 minus B, minus 3B is equal to negative 11. If you haven't gotten this far, pause the video, solve for B, and then use that value of B to solve for A. If you've already got it, don't bother, let's keep doing it together. So I want to get B by itself. Let's start by doing some distributive property. 2 times 7 is 14. 2 times negative B is negative 2B. And then I carry down the rest. Negative 3B equals negative 11. From here, let's combine some like terms. Negative 2B minus 3B is negative 5B. So 14 minus 5B equals negative 11. To get B by itself, let's start by subtracting 14 from both sides. That gives me negative 5B is equal to negative 25. And then to get B by itself, all I need to do is divide both sides by 5. B is equal to positive 5. Now again, critical thinking caps, where is the strategically wisest place to substitute this value of B back in? Well, thinking smarter, not harder, notice that in this equation over here, my goal is to solve for A. I've already got A by itself there. Let's use this equation. It's the same one as the first one, just rearranged a little bit. So from here, by substitution, if A equals 7 minus B, that tells me that A should be equal to 7 minus the value of B that we found from down below, which is 5. If A is equal to 7 minus 5, then that means A should be equal to 2. A equals 2, B equals 5. As an ordered pair, how would I write this? Well, A comes before B in the alphabet. So in ordered pair notation, I should put the A first, followed by the B.